Today we're talking about linear inequalities and one variable. Now I've written a few notes up here for you. These brackets right here are going to indicate that the endpoints are included. They're the squared off brackets. In high school you might have listed that as a closed ball, might have been how we described it. And the parentheses, or the curvy brackets, are what we're going to call our exclusive brackets, which means that our endpoints are not included. So I'll draw a little closed ball and an open circle there so that you will remember those. But we won't be using closed ball and open circle. We'll be using squared brackets and rounded brackets. Also, if you multiply or divide both sides of an inequality by a negative number, remember to flip that inequality because that changes the direction. The negative sign changes direction of things. So let's do our little notational exercise here. Let's say we have negative 2 is less than x and x is less than or equal to 5. In order to describe this graphically, I will draw a one-dimensional graph. On it, have a negative 2 and a 5. This particular set of conditions indicate that x is in between negative 2 and 5, so I'll shade that in best I can so that whoever's watching this knows that x is in between negative 2 and 5. Now I need to deal with my endpoints. My negative 2 is not included, so I'll make a curvy bracket best I can. Then my 5 is included, so I'll make a squared off bracket. Once again, there we go. There's my graphical notation. For interval notation, you just basically write down what's on the graph. And on this right-hand side, I'll need a squared off bracket. And that says that x is in between negative 2 and 5. Now looking at something where we can do a little manipulation, let's look at 3x is, let's say, less than or equal to, how about negative 15? Now I need to figure out what x is and graph that and write it in interval notation. You might be asked for graph notation. There he is. That's graph notation right there. Graph. And this would be called my interval notation. So be sure and read the directions and give them what they're looking for. If they're asking for interval notation, don't put it in graph notation. Write down what they ask for. I'm just going to show it to you in both methods. For this one, I'll divide both sides by 3, asking myself the question, did I multiply or divide both sides by a negative? And I'm going to divide by a positive 3, so no, I did not. So I just keep that same inequality symbol, and then I'll say that x is less than or equal to negative 5. Writing this in graphical notation would look like, oops, I draw my little graph, put a negative 5 on there. Noting that x is less than this, I'm just going to follow the arrow basically. I'll shade in the fact that x can be any of these values less than negative 5. And am I going to need a square bracket or a curvy bracket? Looks like I'll need a squared off bracket to show that it includes the endpoint. There I go. That's my graphical notation. Writing it in interval notation, just read it off the graph. This arrow represents negative infinity on up to negative 5 with a squared off bracket indicating that negative 5 is included. We have a nice little linear problem to solve here. We need to figure out what x is greater than or less than. So I need to get all my x's on one side, all my numbers on the other. I'm going to bring this 8x over to the left. I'll subtract 8x from both sides. So that will be negative 2x minus 4. And then I'll have a 2 over here. Now, did I multiply or divide both sides by a negative number? Nope. I just subtracted 8x, so I keep my same sign. I'm going to add 4 to both sides, so I'll have negative 2x, and then add 4 would be a 6. Did I multiply or divide both sides by a negative? Nope, I did not, so I'll keep my same sign. Now I'm going to divide both sides by a negative 2. I'll have an x, and I'll have a negative 3 over here. Did I multiply or divide both sides by a negative? Sure did, because I divided by a negative 2, so I'll flip that sign. Here's my graphical notation. I'll put my -3 on there. Shade in everything that's greater than -3. And am I going to need a squared off bracket or a curvy bracket? Looks like I'll need curvy. So I'll draw my little curvy bracket. That's my graphical notation. And this would be my interval notation. Looks like we got another little linear inequality to solve. This one's called a compound inequality because I have 3 little chunks there. Do you see my 3 little chunks with me? I'll kind of underline them so you see our 3 chunks. Now whatever I do to one thing, I got to do to all 3. So here I go. Well, first thing I'm going to do is just going to distribute because I can't really see what I need to do quite yet. So I'm just going to distribute this -3. So I get a -3x, and then -3 times my 1 is going to be a -3. And it looks like I need to clean it up just a little bit more. So I'll have -3x, and 2 minus 3 is a -1. So I'm good there. Got this less than, I got 20. Now I'm going to start doing stuff to all 3 sides. And whatever I do to one thing, I got to do all 3. Same thing as I normally would. I need to get this x all by himself, so I'm going to add 1 everywhere. Now, I did not multiply or divide by a negative, so I'm keeping this sign the same. Then I'm going to divide everything through by a -3. Oh my gosh, I said I was going to divide everything by a -3. That means flip all these little dudes, doesn't it? All right, there's my... Oops, I didn't flip him. I better flip him. Let me get my little eraser. Erase it there. And then flip it. I was carrying on. All right, now he's flipped. That's my graphical notation. I'm going to write... that's my... Actually, it's called set notation there, but I'll do my graphical notation. Got to write these things in order. -7 is here. -1/3 is here. And x is in between these two guys. He's greater than the -7, and he's less than the 1/3. So I'll shade in between here. Then got to decide what bracket goes where. -7 needs the curvy bracket, and the -1/3 needs the squared off bracket. There's my graphical notation. Writing in interval notation, it would be -7 and -1/3 with the squared off guy. All right. In solving absolute value problems, there's always 2 possible answers. So you got a mess on your hands here. You've got to break this thing apart into 2 possible answers. So I've got x minus 3 over 2, and looking at the positive case, looking at the negative case, x minus 3 over 2, less than or equal. Now why in the world did I flip that inequality? Well, because I'm looking at the negative case, and that changes the direction. So I'll multiply both sides by 2. X minus 3 greater than or equal to 8, and then x is greater than or equal to 11. Over here, let's see, we have x minus 3 less than or equal to -8. So x is less than or equal to, add 3, be -5, it looks like. So it looks like x is greater than 11. So let me put my little numbers on here. It's greater than 11, but he's less than -5. So this goes in totally opposite directions. I've got this guy, where we can include the endpoints because it can be equal to. Oops, that's not really looking squared off. I'm trying. All right, and then I have the x is greater than 11. Shade that in. With another squared off guy. I think it's probably just better just leave it like that. And then there's my graphical notation. I need to write an interval notation. So let me move this thing up just a little bit. And for interval notation, we've got this end here, -5 with the squared off bracket. Now the symbol in mathematics for OR is this union symbol. So it means that X can be in this little section or X can be in this little section. And that's what we'll use for interval notation. We'll use this union symbol or this OR. And that's it for section 1.7, I think.